Okay students, now in the English medium mathematics lessons, today in the lesson I will discuss equiangular triangles, right? So this is my first part of equiangular triangle. Next I will discuss the second part. So in this equiangular triangle part, students, right? So this part I will discuss with you ratio of length, right? How to write ratio using the length, right? So this is very important part to a student, right? So this is a geometrical part, geometrical lesson. You get each equation right in the GCO level exam, so keep in touch. Now student, ratio of length, right? Now see student, you can see here a straight line segment, right? So this is a straight line segment. Right now, I'll mark this straight line segment as this point A, this point as B. Right now, you can see. Now I'll mark another point here. Right, so this point I name as that point C. Now, for example, student, I take length of A to C. That means AC length. That is 5 centimeter, and also C to B length. Right, so that is 2 centimeter. Right, so you can see, student, now AB straight line segment I mark to 1 point, right? So using this length, now I am going to write, student, ratios, right? Ratios of this length, right? So see one here. First one is AC length is to CB length, right? So AC length is to CB length, right? So when you write in numbers, student, length are given in centimeter, both in centimeter. So if you write in ratio, no need to write units, right? So that means you can write AC length is 5 centimeter, CB length is 2 centimeter, right? So in order you have to write, so that is one ratio. Then this AB line divided by C point, then I can write another ratio. See my ratio, AC length, that means this part is to AB, that means whole part, right? This length is to this whole part. Now when you write in numbers, what happens, student? AC part, that is 5 centimeter, right? AB part means whole part, that means 5 centimeter plus 2 centimeter, that is 7. So ratio is 5 is to 7, right? Let's see another one, CB, right? So this part CB is to AB, that means whole part, right? So first term CB, that is 2 centimeter, AB means that is 7 centimeter, right? Let's see another one, AB means whole part is to AC, this part, right? So when you write in numbers, AB is whole length, that is 7, AC is 5 centimeter, right? So those are the ratio of length, right? So many ratios you can write, right? So now student, this ratio you can represent as a fraction also, right? So when you go to questions in the equiangular triangle, student, you need the fractional form, right? So let's see how to write this fraction, student, right? See, fraction form, uh, AC is to CB, you should write AC in the numerator, CB in the denominator, right? So then this part should be same way, first term numerator, second term denominator, 5 over 2, right? So that is the fraction form, right? So let's see another one, this also can write, right? So I say this one, right? AB is to AC. Now I write the fraction AB numerator, first term, AC second term in the denominator. In numbers we have to write first term 7, that should be in numerator, second term in denominator, right? So that is how to write ratio of length. Now move to students, this way. See, this is one straight line segment, you can see here, one straight line segment, then this is another straight line segment, then another straight line segment. Now you can see, student, I have drawn three straight line segments, then form a triangle, right? So now I name this triangle, student, as ABC triangle. Now I mark point here. Let's see here. This is one point on AB line, so that point is named as D. Then I put this length, right? You can see here AD length is 3 centimeter and DB length is 2 centimeter. Then I mark another point on the AC line segment, so that point is named as E. So I take this length is 1 centimeter and E to C, that is 5 centimeter. Then I mark another point here. You can see point on the CB line segment, that point is F. So length are 3 centimeter and 4 centimeter. So earlier I explained you using a one straight line segment, student. Now here three straight line segments, right? So now see how to write ratio, right? You can write ratio using the AB line segment or AC line segment or CB line segment, right? So I'll explain you one ratio, right? This is ratio, student. See, I take AD is to BD, right? So that means ratio between this AB line segment, AD, that means this part, into DB. So if you write numbers, AD is 3 centimeter, DB is 2 centimeter, that is 3 is to 2, right? So that is a ratio. Then I write another ratio, student. See, using the AC line segment, right? AC. Now I AC, that whole length is to EC, that means this part, right? Now if you write in numbers, what happens, student? Whole part means 1 centimeter plus 5 centimeter, that is 6 is to EC part is, student, 5 centimeter, 6 is to 5. Then I write another ratio bit using the CB line segment, right? CB line segment. So CF means this small part, CB is whole length. When you write numbers, first term CF, this part, that is 3 centimeter, whole part is 3 plus 4, that is 7, right? Now students, see early we represent this ratio as a fraction, right? So now we see how to simplify, how to represent this fraction. This one, right? AD over DV, right? First term 3, that is second term 2, right? So that is numerator and denominator, right? See another one, CF is to CB, right? CF over CB, that you can write as 3 over 7, right? So when you write in ratio, you can represent that one as a fraction. Now we move to a theorem, right? So that your lesson has a theorem. So see, this theorem says, student, right, important part, a line drawn parallel to a side of a triangle divides the other two sides proportionally, right? Proportionally, that means equal of two ratios, right? So let's see using a figure. So I have drawn here this, you can see, student, line AB has drawn parallel to the side of PQ of triangle PQR, right? So let's see, student, PQR triangle, right? PQR triangle, one straight line segment, another one. So I name as this triangle as PQR. Now you can see here, student, the line AB has drawn parallel to side PQ. This is the side PQ. So should draw a line parallel to this PQ line. So that means this type of line. So these two lines are parallel, right? Parallel. In this side you can name as AB. Right? So that is what I take. Then what is theorem say, student? A line drawn parallel to a side of a triangle. Here see, AB line has drawn parallel to a side of a triangle, right? So then say divides the other two sides. What are the other two sides? So this is a, we take parallel line. Other two sides is PR is one side, RQ is another side. So that one, PR divide by A point, RQ divide by B point. So those two divides proportionally. That means ratio. See student, what is proportion? Here RB is to BQ, so that is my ratio between length. You can write so many ratios here, right student? Now according to this ratio, you should write the ratio between this length. Now RB, that means you have to take RA, right? BQ, this part, that means AP, right? So this is the proportion. This is the proportion. One ratio equal to another ratio, right? So you can represent this proportion as a fractional form. That is important one, right? So let's see, earlier we discussed here RB is to BQ. You can write RB over BQ, right? So then other part you can write same way, first term numerator. Here you can see here first term numerator means RA over AP, right? So this is the which we use using to solve problem, right? So this is the say the theorem say, right? So this is what theorem say, right? Let's see another ratio student, right? So same thing, RQ, this part, whole part, is to RB, this part, right? So according to this ratio you can write ratio between this RP side. How? RQ whole length, that means you have to take RP length, and here RB, this part means you have to take RA part, right? So RP is to RA. This is the proportion, right? You can represent that one as fraction, student. RQ over RB is equal to RP over RA, right? So those are the theorems say. Okay, now students, I am going to explain another important part, right? So above theorem state, student, line drawn parallel to a one side of triangle. Now you can see, student, in a triangle we can draw line parallel to another side in three different ways. See student, I explain. So this is my triangle, student, right? So this one PQR triangle. Now I am going to draw a line parallel to PQ side. So this is the line parallel to PQ side. So this AB line, you can see, student, I have drawn inside this triangle, right? Inside this triangle AB line is drawn parallel to PQ side inside the triangle, right? Then see student, this is my PQR triangle, PQR triangle, right? So then this PQR triangle, student, right? Right. Now students, right? So this is my PQR triangle. So now I have drawn, see student, line, right? So this line is parallel to PQ line, but this line has drawn outside the triangle, right? So line drawn, see, this is AB line, right, parallel to PQ side, but line has drawn outside the triangle, right? So if you produce this RQ side, right, and RP side, you meet the A point and B point, right? So same thing, AB line segment, here AB line segment has drawn parallel to PQ line segment, but here inside, here outside, there is one way you can draw this AB line segment. How? See student, see, this is my PQR triangle, right? Now I have drawn this AB line segment, here inside, here outside, but that is down. Now I have drawn line segment here. You can see this is parallel to RQ side. Now if you produce this RP side, right, and also QR side, you meet the A point and B point, but A point is on the RP side, that means this PR side, be careful, P point is on the produce QR side, right? So here you can see line has drawn parallel to side inside the triangle, outside down, outside up, right? So these are the three ways we can draw a line parallel to another side of a triangle. Now you can write ratio between length, right? Let's see RB or BQ. Here see students, this one, right? So if you go to this figure, RB is small part is to BQ, right? So then this length RA is to AP, right? So this one is true for this triangle also. Why? RB whole length is to BQ, this small part, whole length is to small part. In this one, whole length RA, small length AP. Student, remember this one, that is true for, see, RB means RB, this is small part, right, is to BQ means whole part now, right? Then this side up, what happened? Small length means we have to take this small length, right? RA. Then here BQ means whole part means AP, right? So true for any triangle. Now you can represent this one as fraction also, student. You know that, student, RB over BQ is to equal RA over AP, right? So nice one. Okay, student, now let's move to examples, right? Problems. So my first example is, student, this one. You can see here in triangle ABC, the line PQ is drawn parallel to AC. So find the length of AP side if CQ is 4 centimeter, QB is 2 centimeter, and PB is 3 centimeter. Now see, student, I have drawn here a triangles, right? See here, this is my A, B, right, C triangle, right? So ABC triangle. Now you see, student, the line is drawn parallel to AC. This is my AC side. So should line drawn parallel to AC side. These are the PQ line segment. PQ is drawn parallel to, these are parallel, right? We put a arrow mark, right? So then length are given, so you have to find the AP length. Then if CQ length given, right? CQ length is small part 4 centimeter. Then QB is given also, this part is 2 centimeter, and PB is also given 3. You want to find AP, right? So that one take as x centimeter. Now you can see, student, theorem say if a line drawn, you see, line drawn parallel to another side of a triangle, other two sides CB and AB divide proportionally. Now you can write a proportion. Now see, student, we want to find this simple x. That means we should write this AP length, right? So without this AP BQ, I write this x and 3 centimeter using, right? So then I can write this in ratio between these length. How? X, right? So the first I'll write this one, student, right? 4 is to 2, right? So this is small part into this is small part. Then according to that one, I should write ratio, right, between these length, right? What is where 4 centimeter means that is x, right? X is to 3, right? So this is the proportion. Now to find the x, student, we can represent this one as a fractional form. What is fractional form? Right? 4 in the numerator, 2 in the denominator, then x is numerator 3. Now what is all? Fraction equal to fraction. That means we have to cross multiply. That means 2 multiplied by x, that is 2x, 4 multiplied by 3, that is 12, right? Then you can divide by 2, then you get x is 6. X mean the length of side AB, right? So that is 6 centimeter, right? So easy to apply the theorem, right? Okay, now move to another example, student, right? So this is my second example. You can see here, in the triangle ABC, the line D is drawn parallel to BC. We should find the simple X and Y, right? So see here, this is my ABC triangle, student, straight line segment, right? So this is the ABC triangle, right? See, student, the line DE is drawn parallel to BC. This is BC side, right? So the line drawn parallel to BC this way, right? DE, right? That line is D. That is parallel. That means you have to put arrow mark, right? Then find the length of simple X and Y, right? So these are the simple X and Y this way, right? So they have given AD is X 5 centimeter, this part 5, then DB is 3 centimeter, this is small part 3 centimeter, then EC they have given, that is Y centimeter, then ACC whole length, that is 12 centimeter, then this is very right. Now you can see, student, I can write a ratio, right? So here I want to find Y. Now you have see, student, this DE line is drawn parallel to BC. So that means theorem say other two side, that means AB side and AC side divide proportionally. That means you can write any proportion, right? You can write ratio, another ratio. Now want to find Y. That means this small length should be there, right? Otherwise you can't find Y. Right, now Y, right? So I write one ratio with, student, this AC line segment whole length is given, that means whole length to Y, right? So 12 is to Y. Then according to that one, I should write a ratio between this AB line segment. If you take the whole length first, you have to take the whole length first. That means whole length is 5 centimeter plus 3 centimeter, that is 8 centimeter. Then small part here, Y, according to that one, corresponding is 3 centimeter, right? So this is the proportion. Now you can write this one as a fraction, student, right? How? This 12 over y, 8 over 3, right? Cross multiply, 8 into y, 8y, 12 into 3. I write that way. Then if you divide by 8, then you get y is 4.5 centimeter. That means EC is 4.5 centimeter. Now move to another example. This is my third example, student. In this example, I discuss with you how to find the two values, right? So this is what to find X and Y. So this is my figure, right? So you can see, student, here ABC is one triangle, ACD is another triangle, right? So then we have to find simple X and also simple Y, right? Now to find simple X, student, I consider this ABC triangle. This is ABC triangle. Now here DE line is DF line is drawn. DF is drawn parallel to BC side. That means AB side and AC side divide proportionally, right? So that means you can write a ratio between 8 is to 6. According to that one, X is to 3, right? So that is a ratio you can write using the ABC triangle, using this AB and AC length. Now you can write this one as a fraction, student, right? 8 over 6, that one same as X over 3. Then cross multiply, 6 multiplied by X, 6x, 8 into 3. Then if you divide by 6, you get X is 4 centimeter. Then to find the student Y, we should go to ACD triangle, right? So the ACD triangle. FG is drawn parallel to CD. That means other two side AC and AD divide proportionally. Now write the ratio. X is to 3, right? So small length is 3, small length, then 6 is to Y, right? So that is the proportion. Now early we found X. Now you can put here X as 4 is to 3 is equal 6 is to Y. Then I can write as a fraction 4 over 3 is 6 equals 6 over Y. Then cross multiply 4y into 6 into 3. Then divide by 4, student. You can take Y is 4.5 centimeter. Easy one. Now student, in the coming up next part, I'll discuss with you equiangular triangle part 2. That is more question about the equiangular triangle. Important one. Keep in touch with Maths Globe YouTube channel.